So let us start discussing regarding the breakpoints. So as we know that what is breakpoint? Breakpoint is nothing but a point where root locus meets intersection point of root locus branches, right? So it is a point where the root locus branches leaves or enter into the real axis. So we need to find the point. Means we know that the root locus always start from the poles and ends to the zero. So we just have to find the breakout or breaking point, right? So jahan par, okay, so let us discuss all the points one by one. So the point where root locus leaves, right, root locus branches leaves is called as breakout point, and whenever the root locus branches enters, it is called as break-in point. So what we are interested in finding the values of breakout point and break-in point. Now see, the root locus enters or leaves the real axis with an angle of plus or minus 180 degree divided by n. What is n? N is nothing but number of root locus branches. So there are some points. So what is point number 1? Whenever the poles are adjacent between, right, placed between, then there exists a root locus branch, right? Then there should be minimum one breakout point in between the adjacent placed poles. So always remember that whenever there are two poles which are adjacent to each other, and if between the two poles, if root locus exists, there is 100% one breakout point. Okay, so we have discussed this example. So we have plotted this. There are four poles: 0, -1, -2, -3. So we have discussed that root locus lies between 0 and -1 and -2 and -3. So there are two adjacent poles. So point number 1 says that if there are two adjacent poles and if between that poles if root locus exists, then there is always a break point, right? So this is obviously breakout point because always the root locus starts from the poles. So root locus poles से चालू होगा और फिर वहाँ से zeros की तरफ जाएगा. So it is starting from these poles and it will either go, see, root locus is symmetric about x-axis, so it will always be both sides, right? Okay. So what is point number 2? Point number 2 is whenever two zeros are adjacently placed. So yes, what will be there? Then there should always be minimum one break-in point, right? Zeros hai to fir break-in point rahega. So similarly, we have seen that okay, we have there are two poles, 0 and this 0. So two poles, two zeros I have plotted. So here s square, so two zeros are there. So between this, sorry, s square, so two poles are there. Between these two poles always there is a breakout point, and these are two adjacent zeros. So between two adjacent zeros, here I have not made this line between -2 and -3 bold, but it is bold. Means what? Root locus exists between -2 and -3, and hence there is always a break-in point. Okay. So whenever multiple poles or zeros are located at the particular location, then there must be at least one breakaway or break-in point at that location. Like this was the example, multiple poles or zeros, right? So here it was example of multiple poles. Okay. Next point is whenever 0 exists leftmost side of the real axis, to the left of that 0 there exists a root locus branch, right? And then there should be minimum one break-in point to the left of that 0, right? So obviously again we have plotted this root locus, bold वगैरह की है. तो ये दो adjacent poles हैं, इन दोनों के बीच में break out point रहेगा. और यहाँ पर क्या बोला है कि देखिए लास्ट वाला जो poles और zeros whatever it is, right? So here the last one is your 0, right? So -10 के बाद में ना कोई 0 है ना कोई pole है, right? But there is existing one root locus branch which is from -10 to -infinity. तो यहाँ पर 0 है तो फिर ऑब्वियसली लॉजिकली क्या है, 0 है तो रूट लोकस यहाँ पे एंड होगा, तो यहाँ से कहीं से तो भी आएगा रूट लोकस और यहाँ पर एंड होगा 0 पे, तो ब्रेक इन पॉइंट है, राइट? सो ऑलवेज देयर इज अ ब्रेक इन पॉइंट. एंड सिमिलरली व्हेन द पोल लाइज ऑन द रियल एक्सिस टू द लेफ्ट of that pole there exists a root locus branch, right? If there exists a root locus branch, then there is minimum one breakaway point to the left of that pole, right? Next is what is the value of that breakout and break-in point, right? So we are having this method called as saddle point method. So in this method, like देखिए अभी हमें पता है कि हमें यहाँ पर break-in नहीं तो breakout point है, okay? So we need to find out the break-in or breakout point. So this point, what is this point? At what point the root locus will break out, or at what point the root locus will come to the pole, right? So we are interested in finding out the coordinate of this point, right? Breakout or break-in. So we are saying breakaway point. So for that we are having this method. So for that what we need to do, we need to take the characteristics equation which was denoted by d of s plus k into n of s is equal to 0. So what I will do, I will just write this equation in terms of k. So from this equation I can write k is equal to minus ds divided by n of s. And then see what I will do, I will just differentiate it with respect to s, and then I will just find out the after differentiating I will get a equation in s, so I will find out the roots of that. Okay, so what I'm trying to do, I'm trying to find the value of s, and that value of s will give you the valid value of s will always give you the breakaway point. So what is meant by valid s? So the value of s which lies on the root locus will be the valid point, right? So let us discuss in this example. So in this example what we will discuss that okay, so gh is k upon s plus 2. So we are interested in 1 plus gs. So I have written 1 plus gs. So I got this equation, and then I have written this in terms of k. So k is equal to minus s into s square plus 2 into s is 2s. So minus s square plus 2s, and then I have differentiated this k with respect to s. So this will be minus s square का derivative है 2s plus 2s का derivative 2. So I have equated it to 0. So I got s is equal to minus 1, right? अभी देखिए इसका हमें root locus हमें we can plot it the root locus. So it will be 2 zeros are there, sorry 2 poles are there, s is equal to 0 and s is equal to minus 2, and between this 0 and minus 2 root locus exists, right? Now see, obviously the value of s is equal to minus 1 lies between 0 and minus 2, and in this I have means shaded it, or I have made this bold, means what root locus पे s का value lie हो रहा है, right? So hence this is called as your breakaway point, right? तो इसमें अगर s का value अगर -3 आता था तो s is here, right? So that was not valid breakaway point, right? So let us discuss this in second example. So here again gh is there, and I have I have drawn the means existence of where the root locus will exist on the x-axis. So again I have I am interested in 1 plus gh, and then I have equated, and then I got this equation. So I have written this in terms of k. So k will be minus s cube plus 6 minus s6 s square minus 8s, and then I have differentiated it with respect to s. So this was equal to 0, and then I got the two values of s. So this is your simple quadratic equation. So you can use your calculators for solving the quadratic equation. You will get s is equal to minus 0.84 and minus 3.15. Now let us check. Minus 0.84 is between 0 and minus 2, and here root locus branch exists. So this is your valid breakaway point, whereas minus 3.14 is between minus 2 और minus 3. तो minus 2 और minus 4 के बीच में minus 3.15 लाई होता है, लेकिन minus 2 और minus 4 के बीच में root locus का branch exist नहीं होता है, so hence it is not valid, right? So similarly you can calculate it for other. Okay. Now next point is your intersection point on imaginary axis. So now what I am interested in, whether my root locus intersects the imaginary axis. What is our final aim is to draw the root locus, right, on the S plane. So I need to find the intersection point of root locus with my y-axis. Y-axis is your imaginary axis. So this we know, right? So हमें क्या करना है? We have this g of h. So for this very simple method, we know this method. So we have the characteristics equation by using the same rule RH criteria method, right? I have find out this table RH array, and उसके बाद में हमने क्या देखा था कि for marginally stable system what is the value of k. So similarly what I will do for marginally stable system means what I will okay. So this table I have completed as it is in RH criteria, and you can see my video of that. So this I got the value of s as this thing, right? After see, first of all I have find the value of k, right? And then auxiliary equation, what is your auxiliary equation? Auxiliary equation is this, okay? So from here I can get the value of s, and what is the value of s? That is plus or minus j1.29. so means what? It lies on the y-axis, so this is nothing but intersection point, right? So yeah, so what we are doing, we are finding the k marginal, right? When k is equal to k marginal, right, whatever point we are getting, that is your uh, intersection point of the imaginary axis, okay? And then next and I guess last point is angle of departure and angle of arrival, right? So see, whenever the break out or breakaway point is there, right? So from, okay, so whenever the whenever the root locus will start, it will start from the pole. So at what angle it will depart from the pole, or at what angle it will arrive on the zero, right? That is given by angle of departure or angle of arrival, okay? So this is discussed, right? तो यहाँ पर क्या बोलता है कि angle of departure should be calculated at complex conjugated poles, right? And angle of arrival is calculated at complex conjugate zero. बराबर है ना, हमने वही सीखा है क्या कि डिपार्चर कहाँ से, रूट लोकस कहाँ से कहाँ तक जाता है, पोल से जीरो तक जाता है, तो डिपार्चर एंगल कहाँ पे कैलकुलेट करेंगे, पोल्स पे कैलकुलेट करेंगे, कॉम्प्लेक्स कॉन्जुगेट पोल्स पे, और ये एंगल ऑफ अराइवल कहाँ पे कैलकुलेट करेंगे, कॉम्प्लेक्स कॉन्जुगेट जीरोस पे हम ऑलवेज वी विल कैलकुलेट. नाउ सी व्हाट इज द फॉर्मूला? फॉर्मूला इज नथिंग बट phi d. Phi d means angle of departure. So angle of departure is always 180 minus phi, right? और angle of arrival is always 180 plus phi. Now what is this phi? Phi हमने already we know this phi. What is phi? Phi is nothing but argument of this gh, or argument of this gh, right? So argument of the gh हमने देखा था. What is argument of gh? Summation of angle of poles minus summation of angles of zeros, right? So for example, let us say that we need to find the angle for this gh, right? तो हमें पहले देखना पड़ेगा, this is s plus j, s minus j, s plus 1, right? तो हमें पहले देखना पड़ेगा what is the angle of this gh. So angle of gh is nothing but angle of numerator divided by angle of denominator into angle of right, this angle of s into angle of s plus 1, right? तो हमें ये भी पता है, but at what point? At s is equal to j, ये पॉइंट दिया रहेगा. तो हमें वो भी पता है कि एंगल अगर इफ द two complex numbers are in multiplication, its angle will get added, and if the two complex numbers are in division, angle will get subtracted. तो वो पूरा हमने देखा था. तो उससे हमें क्या मिलेगा? We will get the value of theta. So it will be, इसका एंगल है 45, इसका एंगल है 0, इसका एंगल है अगेन सॉरी इसका एंगल है 90, इसका एंगल है फिर से see after substituting we will get 2j, j, 1 plus j. So 2j means 90, j means 90, and 1 plus j means 45. So 90 minus yeah, so this will be your angle, okay? So it will be 90 minus 90 plus 45, whatever it is. So your angle will be summation of poles minus summation of zeros, right? It is, yeah. So it will be this 90 plus 45 minus 90, and this you will get phi a, okay? So this is your phi a, and then phi d we can similarly calculate. So I will leave it up to you, and then you can find the angle of departure and angle of arrival